radius. No, I just wanted to explain what arc length is for our lesson today. Yeah, so if you look at the pie, the amount that I have eaten already would be represented by this arc length, this portion of the circumference, and the amount of pie left would be represented by this part of the circumference. So that's arc length. It's when you measure the outside part of the circumference. You know, for example, if I were going to cut a piece of the pie and just leave half of it, then I could measure how long this arc is. Let's review circumference. If we measure the radius and then go around the circle, 1 radius, 2 radius, 3 radiuses, just shy of half a circle, 4 radiuses, 5 radiuses, 6 radiuses, of course shy of a full circle, we learned already that that is 2 pi radiuses around the circle. That is circumference, 2 pi r. You previously memorized this in geometry, but now you can see exactly why. In part A, we have a circle whose radius is 4 centimeters. To find the circumference, we easily go c equals 2 pi times radius, which is 4. Circumference equals 8 pi centimeters. I'm going to leave it exact instead of multiplying in by 3.14159. The problem is that that is all the way around, and we were actually asked for the arc intercepted by the central angle 30 degrees. So what we want is just the length of the circumference here. If we look at the yellow portion of the circle, then we know we want a fraction of the circle. What fraction is that? Well, we want 30 degrees out of the entire circle, 360 degrees, part over whole. So now to find arc length, we can go ahead, we use S for arc length and say, well, we have the circumference, but we only want 30 degrees over 360 degrees of it. So let's go ahead and figure that out. Circumference was 8 pi. I happen to know 30 over 360 is 1/12. Multiplying that together, 8 pi 12ths, which reduces to 2 pi thirds, or approximately 2.094 centimeters. In part B, we're challenged to find the length of the intercepted arc if the radius is 4 centimeters and the central angle measures pi 6. So we learned in the last example that S, arc length, equals circumference times part divided by whole of the circle. So S equals circumference, 2 pi r, times theta over whole. But this time we're in radians, so all the way around the circle is 2 pi. Oh, look at that. This is very interesting. We can divide out the 2's, divide out the pi's, and look at the formula we've just derived. S equals radius times theta. Therefore, I can go ahead and plug this in. S equals 4 times pi over 6. That is 4/6 pi, and that reduces to 2 pi thirds, which in fact is the exact same answer for part A. Let's go back up to the top of our page. If theta is given in degrees, then we would do 2 pi r circumference times theta divided by 360 degrees. If theta is given in radians, it is simply radius times theta. Now try C and D.
Pierre, what are you still doing in bed? Come on, we gotta go. Pierre, what? Pierre, what are you doing? Come on, Ryan, let's dance. Someone's got to get some work done. Okay, so let's check your C and D. In part C, we wanted to find the length of the intercepted arc with a radius 2 inches and a central angle that measured pi over 3 radians. So we needed to use the arc length formula for radians, S equals r times theta. Then I plugged in my given radius and my arc length and got 2 pi over 3 inches, or approximately 2.094 inches for my intercepted arc length. For part D, our radius was 5 meters and our central angle was 87 degrees. So this time we needed to use the degree formula, S equals 2 pi r times theta over 360 for our arc length. So after plugging in my radius, 5, and my central angle measure 87 degrees, I got 87/36 pi meters, or about 7.592 meters as my arc length.